Hello friends, I welcome you to my YouTube channel MacPM. So in today's operation research video, we will solve another video on linear programming by using graphical method, which is multiple optimal solutions. In previous videos, we have seen that every objective function has only one solution for maximization or minimization with given constraints. But in this video, we will find out that we can have more than one optimal solution for the same objective function. So let's go ahead and solve this question. So you can see that we have objective function which is 10x1 plus 6x2, z is equal to 10x1 plus 6x2, and our constraints are given as 5x1 plus 3x2 is equal to 30. We have written equal sign because first of all we will convert these inequality into equality signs so that we can easily find the intersections and points where these lines touch the x-axis and y-axis. For simplicity, we have converted in equality sign. Then later on, after drawing the lines and the graph, we will use inequality sign to find out the feasible region of this inequality. Now second one is x1 plus 2x2 is equal to 18. x1 is 0, x2 is 0. So these are four are the constants. So 5x1 plus 3x2 is equal to 30. So we can see that if we put x1 is equal to 0, then 3x2 will be equal to 30 when x1 is 0. Okay, so x2 will be 30 by 3, which is 10. So our intersection point will be 0 and 10. If we are solving for this, if x2 is 0, then 5x1 is equal to 30. So x1 is 30 by 5, which is equal to 6. Now similarly for this equation, if x1 is 0, so here it point was 6 in 0. If x1 is 0, then 2x2 is equal to 18. So x2 is equal to 18 by 2, which is equal to 9. So point of intersection is x1 x2 is 0 and 9. If x2 is 0, then here x1 is 18. Okay, so we have found the intersection points. Now we will draw the graph. Suppose this is x-axis, x1 axis, this is x2 axis. This is 2. We will divide this graph into divisions. Now our first line is 0 and 10. So x1 is 0 and y1 is x2 is 10. So this point and another point is 6 0. 6 0. So it is 6 0. This is 0 10. So this is our first constant, and second line is 0 9 and 18 0. 09 is here, and 180 is here. Okay, so and x1 is 0, x1 is 0 here along x2 axis, and x2 is 0 along x1 axis. So what are the inequalities? 5x1 plus 3x2 is less than or equal to 30. So it will be this side. We will mark with a different color. And the second one is x1 plus 2x2 is less than or equal to 18. So in this case here, and x1 is greater than 0, here, and f2 is greater than 0 here. So you can see the common area is this one. So this is feasible solution region. So we will mark different points A, B. We have to mark the extreme point C, D, so that we can find the solution at these points, value of Z. So what is the point coordinates of the point C? We have not calculated it. So coordinates of the point C can be found out because these two lines are intersecting at point C. So we can solve these two equations. 5x1 plus 3x2 is equal to 30, and x1 plus 2x2 is equal to 18. Okay, so if we multiply this equation by 5, then we will get 5x1 plus 10x2 is equal to 90. This is equation number 1, suppose. This is equation number 2. So if we deduct it, then we will get 5x1 minus 5x1 is equal to 0. 3x2 minus 10x2 is equal to minus 7x2 is equal to 30 minus 60 is 30 minus 90 is minus 60. So x2 is 60 by 7. So if put this value in equation number this, suppose 2a, then x1 plus 2 into 60 by 7 is equal to 18. So x1 is equal to 18 minus 120 by 7. So x1 is, if you solve this, you will get 126 minus 120 by 7, which is equal to 6 by 7. So coordinates of point C is 6 by 7 and 60 by 7. Okay, so we have to make a table to solve this problem. We will write the points, then coordinates, then value of Z, value of Z, which is we have to maximize objective function. The value of Z is 10x1 plus 6x2. So what are the points? Point A, we have to select only extreme points, point A, B, C and D. So point A is 0, 0, which is origin. Point B is 6, 0. Point C is 6 by 7, 60 by 7, and point D is 9 0, sorry 0 9. So value of z will be here 10 into 0 plus 6 into 0, which will be equal to 0. Here it will be 10 into 6 plus 6 into 0, which is 60, and here it will be 10 into 6 by 7 plus 60, sorry 6 into 60 by 7, which will be equal to 60 by 7 plus 360 by 7, which will be equal to 420 by 7, which will be equal to 60, and here it will be 10 into x1 is 0 plus 6 into x2 is 9, so it will be 54. So you can show that at 2 points B and C, at 2 points B and C, we are getting the maximum value of z. So we have more than one solution. Actually, if you see this, if you see the problem, 10 and z is equal to 10x1 plus 6x2, and this first constant is 5x1 plus 3x2. These two are having the same slope, which is equal to 6 by 10, which is equal to 3 by 5. Here also 3 by 5. So you can say that these two lines are parallel. So actually all the solutions along this point B and C will have value of 60 only. So we have many solutions. So maximum value of z is 60, and you can choose any value of x1 and x2. Here you can see x1 is 60, and sorry, first point is 60 and second point is 6 by 7 and 60 by 7. You can choose also many values along this point, this line BC. So you will have more than one solution. So you can choose different combinations and still you will have maximum value of z. So this is a problem which is having more than one solution. If you understand this problem, then please subscribe to our channel and comment if you don't have any doubt. Thanks for watching this video.